Modified post correspondence problem. So the definition of modified post correspondence problem is given two sequence of strings w1, w2, wn and x1, x2, xn over some input symbol sigma. The solution to the problem is to find a non-empty sequence of integers I1, I2, etc. up to ik such that W1, Wi2, Wi3, etc. up to Wik is equal to x1, xi2, xi3, etc. up to xik. Now, if you have not watched post correspondence problem, better watch post correspondence problem, then come to modified post correspondence. See, if we have a look at the post correspondence problem definition, it is very similar. So given two sequence of strings w1, w2, etc. wn and x1 over sigma, the solution to the problem is to find a non-empty sequence of integers I1 to ik till this such that the definition of post correspondence problem and modified post correspondence problem is one and the same. And the only difference lies in, see here we can select any sequence wi1, any sequence the xi1, any sequence of integer. It can be either 1 or 2 or 3 or 4. It can start with, see in our previous example, it is the first sequence, we have a sequence of integer we have added is 4. But in modified post correspondence problem, this should be 1 only. You have to select this as your first sequence always. That is the difference between post correspondence problem and modified post correspondence problem. So if we want a solution for modified post correspondence problem, then we'll start the solution to this problem is the sequence of integers. Obviously, the first sequence we have to select for w and x is the first sequence, that is I1 only we need to select. So it will be 1 0 0 1 1, and after that we can try to match with the corresponding things. So we have taken first instance and then we can select 4 or 2. Let me select 4 because next we want w as 1, so have it as 0. So the next sequence I am going to select is 4, and next sequence of strings which I am going to select, next sequence of w which I am going to select is should start with 0. So here 3 starts with 0, so let me add 0 1 here and 1 1 here. So then I can add second instance, so 1 0 and a 0. So if we have this is a solution. This is one instance of modified post correspondence problem in which our w is equal to x, So in problem they may give you a table with two sets of sequence of strings as w and x. In some textbook we'll have w will be represented as a and the next sequence of strings will be represented as b. In some sequence they'll be giving this wx as some Dominic pairs like this 0 1 numerator denominator combination. First one, second one 1 0 and 0, third one 0 1 1 1 like this, 1 and 0. Some examples they'll be asking questions like this in which you have to consider the numerator as wi and denominator as xi's. Okay, you need to consider like this. In some problem they'll be telling you a card, like a card is having two sides. One side is having 0 1 and the other side is having 0 1 1. So one side we'll consider as wi and the next side we'll consider as xi. So this problem can be asked in any of these ways. Okay, so this is a very simple example for modified post correspondence problem. So if we understood what is post correspondence problem and modified post correspondence problem, then we will, in next lectures, we will try to convert a Turing machine to its MCP. We will study about the rules for converting Turing machine to Mpcp.